So what this is a kind of a next layer on the internet. One of our colleagues is Dave Reed, who's the slash in TCP/IP. So there's another. It's a good way of saying it because he was instrumental in the separation out of those two ideas that are so useful today. And the basic idea here is that the internet itself was designed to solve an n-squared problem, which is how to do point-to-point communication without having a crossbar switch. So it's done using peer-to-peer. When it was done in the late 60s and 70s, it was realized that it was going to make Engelbart's immersive stuff really, really difficult. Because Engelbart's collaboration was done through a server, and there are unfortunately 2 to the n possible subgroups in a network of n people. So this is not a scalable idea. It's much less scalable than n squared. And so Dave Reed and other people started thinking about how could you do this 2 to the n problem as a completely peer-peer, non-server way of doing things. And so let's see if the demo gods are with us, David.
Okay. I'm definitely over there?
Yeah.
Okay. What you're going to see here is, as Alan said, this is what I think of as a broadband conference call. And just to get things going, hopefully. Do you see anything happening on the right?
Yep.
Yes? No?
Yes, we do.
Oh, okay. No? Yes? Sage. Oh.
The other right.
He's there. I'm there. He's the bunny. I'm Alice. Yeah.
There we go.
Okay.
I'm now moving way out here, and I see Alice here, and Alice is going to the mirror here. So if you look over here, you can see what I'm seeing. So I'm just following.
So I'm looking at right now as a mirror, so I see myself and I see the bunny behind me. The mirror is essentially a portal, but it's a portal into the space we're in. It's actually, this is like a little 3D window. I can turn that around like that, and again, resize it, and pick it up and move it. It's probably the least interesting portal that you're going to see in just the next few minutes. Over here is our friend over there, but just to prove that looks like deceiving news. And then over here, we have a little pyramid. Now what's happening is everything I do is shared over there with what he's doing. Essentially what we've got is a true shared space.
It's a replication architecture that's doing real-time transactions over the slow internet.
Right. And what's really cool about this is, in a sense, it's a late binding protocol. All these objects have their own messages associated with them. But what happens, and they're all different. All objects have different capabilities and things that they do. But what's nice is that we don't really have to worry about a master protocol. Every object is different, but can then communicate to the rest of its peers to ensure that we're synchronized.
So it's rather, the fun part is a little bit like the web in the sense that when you go somewhere that you don't have the stuff, it comes to you like a web page does. Unlike the web, though, you don't just get a copy. You get a copy that's part of this massively parallel real-time transaction stuff, so that when you do stuff to it's reflected in what you might call psychological real-time to everybody else. And people are interested in how that works. We'll explain it a little bit later.
Okay, now what I'm going to do is go into a true portal. This is our vision of Mars. And what's nice, remember, this is a kind of a window, a door into that space, but I can actually move it around, kind of like the mirror was, except I'm looking into another space. Well, we think of these as the links into another page, if you will, except it's live. And what I can do is literally drop into that space. In fact, if I turn around, I should be able to watch Alan come through. And there he is.
One thing that's worth mentioning here is I am doing this part of the demo on, we try and use different machines as we go. This is an ultralight. This is a 2-pound machine. that is doing my point of view on this system. Dave has got a little bit more of a gunboat kind of machine.
And mine's the one that has the problems. So this is a little robot that we built. It's
I'm going to
actually
get up on top of this rock so I can
Sojourner.
see you.
And what I'm going to do is start it going. And what's nice is I'm literally controlling both versions, and I can drive it around. Notice, by the way, I should point out one thing. This is all written in Smalltalk. We're using OpenGL at the bottom, but the rendering engine that I wrote is 100% Smalltalk, or Squeak, which I find, I was just totally impressed by what I could do. It allows you to think in a completely different and very powerful way. I didn't learn this, learn how to program Smalltalk until about a year and a half ago. So anyway, that's that, but it shows that a remote control of that object. Next, let's go to the flag world.
Okay, you go your way and I'll go my way.
Yeah. Here's another portal, and what I'm going to do is go through this portal to yet another portal over here, and what we have is a little simulation running on top of that. Are you?
I'll close it.
Okay. And I'll watch you come down the stairs. This little escalator. This is actually a little tribute to Scott Fisher and Warren Robinette's work at NASA. Who that was. I don't know if you've ever seen that work, but that should be included in Alan's presentation.
It's too recent.
Yes. That was the 80s.
Okay. Go down.
Over here we have a little flag. I'm going to show you there. This is actually a mass spring simulation. It's not a pre-canned thing. And actually what I'm going to do is release the flag just to prove that. And then I'm going to crank it back. So really actually calculating the little masses and springs.
So this is like that particle system, except they're connected by springs and they're pulling fragments of the flag textures around.
So
I should give you a little spin, shouldn't I, David?
So what Alan's doing right now is he literally, I'm on a little carousel, and he just started spinning it. Interestingly enough, we didn't program that explicitly. All that's happening is I happen to be on top of something that's moving, and whatever I happen to be on, I just sort of stick to, and he's changing it around someplace else, so it just works.
Okay.
All right, next we're going to go upstairs to a little underwater environment. This is our other collaborator, Andreas Raab, a brilliant hacker. Actually, he was the person who ported Squeak to the PC. And in here is a little underwater space. What's interesting, actually, Alan, when you come in, I'll watch you.
I should mention here that for people who followed the vivarium stuff that we did 15 years ago or so, this is the modern instantiation.